Yeah. Okay, this is part 2. If you'll remember, last time we talked about basic antenna principles and some of the antenna designs that were used in the golden age of radio, mostly before World War II. Today we're going to look at some of the practical aspects of installing a high-performance antenna in your house to make your old radio play. And the place we're going to start is the good old inverted L antenna, the quintessential radio antenna. Piece of wire as long and high as you can make it out to a friendly neighborhood tree. Lead in down the side of the house. Ground rod out here. Some wires running into the house. Maybe a lightning arrestor at this point. I say by the book here because there are some implications in installing an antenna in terms of building codes and the electrical code. I've never heard of anybody having a legal problem with a receiving antenna, but just so you've heard it once anyhow. The codes generally call for the antenna wire to be number 14 or larger, so it's reasonably sturdy and won't fall down. The ground rod here, which is to head off any potential lightning trouble, is supposed to be an 8-foot long UL-approved ground rod. You can find things like this at Builders Square, also at Radio Shack. Sometimes hard to actually drive an 8-foot ground in, but that's what the code calls for. The ground wiring is to be number 8 aluminum. That's also the size wire that Radio Shack sells. They're supposed to be 3-inch standoffs if this is a piece of wire rather than a piece of coax coming down the side of the building. An approved discharge device at the entry point, what we called lightning arresters in the old days. And the wires coming through the walls are supposed to be installed in insulating bushings. Now, like I say, these are the supposed legal requirements for an antenna. I want you to hear that once. We're going to basically deal tonight with the inverted L, which is the simplest antenna to install because you essentially hang it on your house. You need one other support point away from the house, and the lead-in is down one end as opposed to a dipole where you might have to provide a feed up the middle. It's a good compromise antenna. It'll work for shortwave. It'll work for broadcast. It'll get you some long wave. Okay. Let's talk further about the materials that you're going to build your antenna out of. The wire. Any wire will work. Doesn't matter whether it's insulated or not. Insulated wire may give you an edge if you need to run it through the tree branches. If you live someplace where people object to you having an antenna, you might want to use real fine wire and make yourself an invisible antenna. Again, Radio Shack sells number 14 stranded. That's pretty nice antenna wire. You put it up and it'll stay. It's easy to handle, and it's probably the easiest thing to get your hands on. At the end, you need insulators of some sort. The traditional insulators are good things to use. However, on a receiving antenna, you don't need to have real elaborate insulators. Just some piece of plastic pipe or something of that sort will work equally as well. Transmitting insulators are built to have high voltage characteristics because the voltage at the end of a transmitting antenna can be quite high. So those insulators are fairly sophisticated. For receiving, you don't need to get too carried away. I saw a lot of nice old insulators at the meet on Saturday. You can buy a couple of those for $1 or so a piece. They do you just fine. Radio Shack selling some ceramic insulators. They want something like $4 a piece for it. I don't understand it. I would use something else. Was there a question over here?
Yeah, you mentioned something about using thin wire.
Thin wire.
What is
thin, small diameter.
What's the limitation on the diameter?
There really isn't one. Well, the fact of the matter is that compared to the wavelength and the length of the antenna, number 14 is already so small as to be almost unnoticeable. Yeah, you put up a piece of number 30 wire, it'll pull signals in just fine. You know, a bird sits on it, he'll break it, you know, but
Doesn't matter, copper, steel.
doesn't much matter. I mean, in fact, one of the things that some antenna experimenters use is electric fence wire, which costs about $12 a quarter mile. Okay, so if you need to do it on the cheap and put up a lot of antennas, that may be the way to do it.
Fantastic.
Okay, so we got wire, we got insulators. A lot of times you need something to hold the ends of the antenna up. You can use more wire. Usually you may want to use rope. And this is one of the places you need to be just a little careful. Your usual white polyester or polypropylene rope that you pick up at the supermarket will deteriorate in the sunlight in about 6 months and break and come down. So you want to look for something that's a little bit UV resistant. If you go to the Ham Fest, there's a guy that sells what appears to be military rope. It's braided stuff and it's OD colored, and the pigments in that sort of rope keep the sun from attacking it, and that's the kind of thing you ought to look for. Doesn't have to be thick. 3/16 of an inch polyester rope is plenty strong enough for what you're going to do. Parachute cord be okay too. And like I say, white synthetic rope, you kind of want to avoid that for any permanent installation. So, another word on installation. Have you hugged your tree lately? They really are. If you have trees, that's the obvious thing to stick an antenna on. If you can put a ladder up it and screw a little screw eye in, it won't hurt it a bit. The other approach, the one I like, and I've owned some tall trees, and this is much better than risking life and limb going up the tree. Slingshot, a couple of 1 or 2 ounce fishing sinkers, and a fishing rod, and you shoot the fishing line into the tree, pull some twine up the tree with the fishing line, and then pull your rope up into the tree. You can do the whole thing in 10 minutes and pull your antenna up into the tree. I found that rope like that hanging over a tree branch does not seem to wear through or break or anything like that. Doesn't seem to bother the trees too much either, so you can put something up like that pretty much with impunity. If you're talking about tall trees, and especially tall, thin trees, and you pull the antenna up tight, the wind's going to make the tree sway and break the antenna. So in those kind of cases, a pulley and a counterweight's a real good idea, or a screen door spring sort of situation. I had one spring up that rusted out on me, and I've used pulleys and counterweights in almost all cases. Gallon plastic jug makes a real convenient counterweight. It's just about right for about 50 or 60 feet of antenna. You can go out and spend 99 cents on a bottle of window washer for your car. Either pour it in the car or else put it out and use the blue color as a decorative weight in your yard.
What do you finish out with?
Just the water is fine. If you need more weight, you cut a hole around the top of it and fill it with rocks. But
Freeze in the wintertime, wouldn't it?
well, that's why you use the antifreeze.
Oh, okay.
That's right.
How do you ground it?
We'll get to grounds here in a little while. This was just a matter of hanging things up. In fact, we'll talk about grounding on the next page here. Now, grounding means a couple of different things, and there's two basic areas here we're going to cover. One is the safety aspect of a ground, and the other one is providing a good RF ground, which is the other half of your antenna. Remember that all antennas have two halves, and in the case of a Marconi antenna, which is what an inverted L is, one half of the antenna is the wire up in the air, the other half of the antenna is the ground. So, you need to put a ground rod where that wire comes into your house. You really want to do that because if you get a lightning strike, hopefully what's going to happen is that the strike is going to continue straight down into the ground where the wire turns to go in the house. Yes?
Is there any problem in putting it only 4 or 5 feet from your house ground?
No. In fact, they want you to bond it to your house ground.
For RF ground too.
Well, we'll talk about that just a little bit here as we go. And years ago, they did a lot of studies about lightning safety and things like that, and they concluded that you really did want the 8-foot ground rod to ensure that you had a ground connection in the case of dry climates. So you leave your conscience be your guide. I mean, a couple of feet of copper tubing pounded in the ground is a lot better than nothing. But you probably ought to have a safety ground at the point where the antenna enters the house, directly below it. Now, that ground rod in the ground might not turn out to be a good RF ground. So what I would suggest you try doing is to form a ground network by bonding together whatever grounds you have. One of the obvious candidates is you probably already own an 8-foot ground rod right below your electrical meter. Okay, and in fact, the code wants you to tie your ground into that. So try that. The old cold water pipe is good. The cold water pipe might be the best ground you're going to get without going to really extreme measures. Now, radio amateurs and commercial broadcasters will bury hundreds of feet of wire in the ground, thousands of feet of wire sometimes, to get a really effective RF ground. That isn't necessary for effective receiving antennas. It does become a factor when you're trying to set up a transmitter and not lose a lot of your transmitter power by warming up the earth. But cold water pipe might do it. Parallel multiple grounds together to achieve the best results. And the best results are judged by listening to the noise you hear in your system. If you add the ground and the signal gets louder and the noise gets lower, you did good. If you connect a ground up and now all of a sudden you have a bunch of buzzing and AC power kind of noises, well, maybe that isn't one you want it to hook up to. Okay. You hear the term ground loop. Don't get bogged down in a lot of hypothetical nonsense about ground loops. Ground loops are a very real problem at audio frequencies, and I'm sure Ludwell can tell you a lot of telephone stories about ground loops. But for RF grounding in a radio, as opposed to trying to avoid ground loops, you really just want to tie everything together as much as you can. Several short ground rods may be more effective than one long one, for instance. But cold water pipe might be all the ground you need. Even the ground on your electrical system, the ground pin on an outlet might be all the ground you need for reasonable performance. Yes?
I just needless to say, you got plastic pipes.
Yeah, if you got plastic pipes, forget that. Unless you want to mix a lot of salt in your water. But we're assuming copper pipes here. Yes.
When you say the cold water pipe, you mean like you have to run it in under the house, or can you run it out like to the faucet?
Picking up the faucet outside is a good deal. You can do that just fine. Any place you hook up to that, because normally your plumbing will ultimately be bonded back to the electrical ground and to the earth somehow, like maybe out through your well or out through the service pipes. And even if it's not, you've got these pipes spread all over your house, which is a good amount of grounding. So that's a good ground. That's usually a pretty effective ground. Yes, sir?
You just have to watch out for some place in between you and the earth where they use plastic.
Yeah, that's true.
That's common nowadays, is to have plastic somewhere.
Right.
And you bond onto a piece of copper and it's not
Yeah.
connected.
It might not hurt at all to use an ohm meter to convince yourself that you really have a ground connection, and use the electrical ground as a reference, because like I say, that will almost always be tied. You will almost always have a positive earth ground there. Yes?
The rock salt that you put down around your copper-driven pipe, does that help you establish a better ground?
That's supposed to help, and I could believe that it probably does. In fact, I saw a suggestion the other day that you use 3/4 copper pipe with 1/8-inch holes in it and pour the rock salt down inside the pipe. But like I say, just for openers on a green side up basis, try the water pipe, because that's going to be a pretty good ground, and you can go to a lot of trouble and not have a ground that's that good. But at the same time, do put a ground rod in outside at the entry point to head off a lightning strike. Now, lightning, there's some places where you're not going to have a lightning problem. Your antenna is going to be lower than the electric lines in the street or something like that, and you're essentially protected that way. But probably if there's lightning trouble in your neighborhood, you're going to know it. You're going to have heard the stories or lost TV sets or something yourself. But you do, I think you do positively want to have that ground rod just in case. Okay, so we've got an antenna, we've got a ground rod. How do we get that lightning to go from the antenna to the ground? We used to call them lightning arresters. There ain't no such thing anymore. Truth in advertising. They're now discharge devices. And they serve there's two slightly different aspects of this. One is to head off an honest-to-God lightning strike. You know, the 30 million volts at 7,000 amperes or whatever it is. And you want that to happen right at that point where the wire turns to go in the house. The lightning positively does not want to go around that corner. It wants to go straight to the earth, and you want to help it do that. There's a couple of different approaches. One which was done in the old days and usually isn't practical in an entertainment sort of situation is a big old knife switch that either connects the antenna to your radio or else connects the antenna to ground. That's okay if you're going to deliberately go and operate the radio and now you turn the knife switch. You probably won't do that. There are some commercial discharge devices. The only readily available ones I know of anymore are the 300 ohm TV twin lead devices. Radio Shack sells them, and when we're done here, I happen to have some of them which can be had free to the first people who show up. And you can also gin up something of your own in commercial applications. There's things called gas tubes, which are essentially high current neon bulbs, which will do the same sort of thing, or a spark gap of some sort. There have even been some situations where people have cobbled up automotive spark plugs, and that gives you a place for the lightning to go, as I said. The electrical codes tell us that if you're using coaxial cable for a lead-in, all you need to do is ground the shield of the coax at the entry point, and there are grounding blocks available from Radio Shack and other places that will do that quite nicely. Now, there's another aspect of the static electricity problem, and that is that if you have this wire up in the air with high efficiency insulators at the end of it, and now you have it running down into your house, and maybe you don't have anything connected to it at the moment, it actually forms a big capacitor, and even in fair weather, this thing can accumulate a considerable electrical charge. Not usually a big problem with tube radios, but if you're going to use any solid-state radios, especially like a portable shortwave radio where you're going to clip this thing to the antenna on the radio, you want to do something to make sure that you don't have a 500 volt static charge on there when you touch that antenna, because you're going to take the little old field effect transistor on the front of the radio right out in an instant. So the way to deal with this is you want to provide a DC path to ground, maybe in addition to the lightning arrestor, because I'm not sure what these discharge devices really do. I don't know if they bleed away low voltage charges. I'm not sure. So there's a couple of approaches. I'm going to talk here a little bit about transformers to connect the antenna to a piece of coax cable, and if they're properly designed, they will provide a DC path to ground, and you live happily ever after. Other approaches, you use an RF choke essentially across your lightning arrestor. 2.5 millihenries is a convenient size. There's a lot of those around. If nothing else, a resistor, 100K or so, will not bleed away enough signal to notice, but it will bleed away any accumulated static charge on the antenna. So you ought to do something to provide a DC path to ground. Yes?
You're saying that the static charge should be able to draw, you should be able to draw the static charge off the antenna even when the set's operating.
Yeah. Yeah, I mean, you want to put something in there that you don't have to think about. It just happens all the time automatically. And those are the ways to do it. You know, even the resistor will do just fine. Okay, so we've got our wire up in the air. We've got our connection to the earth. We've talked about how to avert disaster with Mother Nature. We still have the issue of bringing that signal to your receiving set. And there's a couple of different ways to go about this. The old tried and true method, piece of insulated wire comes into your house and runs to the radio. It works, it's simple, but the problem is that now you've brought this clean radio signal from outside your house down into the noise field that exists around your electrical wiring, and now every foot you run that wire further into your house picks up more noise until it gets pretty noisy indeed. That's okay for short runs, but if you have an obvious noise problem or the run needs to be long or both, you probably ought to think about something a little more sophisticated than that. First step is coaxial cable, which essentially puts a shield around your lead-in wire, connect the shield to ground, and it keeps the noise from insinuating itself into the radio signal. That's pretty good for a short run, like maybe 10 or 15 or 20 feet, but that coaxial cable is also a capacitor shunting your signal to ground. So without some sort of impedance matching between the antenna and the coaxial cable, you're losing a lot of signal. So probably the best solution is a broadband matching transformer to take that relatively high impedance signal on the antenna, convert it to 50 or 75 ohms to feed your coax, take it to your set. We're also going to talk here about some other things like perhaps splitters that allow you to effectively split the signal to feed multiple sets. And if you use 75 ohm TV coax, there's a bunch of accessories that can be fairly handy to use. Moving right along. Generally available coax cable is reckoned in the effective impedance of the cable, and the two common values are 50 and 75 ohms. I like the 75 ohm cable that's used generally for TV cable applications. Looks about like this. There's two sizes, RG58 and RG6. The 6 is larger in diameter, has less signal loss, but that's mostly a concern at UHF frequencies. I wouldn't worry about it for the broadcast band or even shortwave. But whatever you can find, you can buy this stuff at Radio Shack. There's also a lot of it just sort of laying around. It's inexpensive. If you get into this in a big way, you can go out and buy, if you buy 500 feet of it, it's about 10 cents a foot. It also has the advantage of inexpensive and easy to work with connectors, the so-called F connector, which is a screw connector, which is crimped onto the end of the cable. The connectors are, in bulk, they're about 10 cents a piece. I think at Radio Shack they're maybe 40 or 50 cents a piece. If you start doing this, if you only need to, and you can also buy lengths of cable that already have connectors on the end of them. If you need to cut cable and install connectors and you only need to do 1 or 2 of them, or half a dozen or so, you can buy twist-on connectors where you take your X-Acto knife and peel the end of the cable and just twist these connectors over the shield. They make good connection, and it's easy to do. If you get a little more sophisticated, there's some tools you can buy. Again, a Radio Shack guy here. If you put that on the cable and twist it around this way, it's got 2 blades in it and does a real neat stripping of the cable in just a matter of seconds. And then you install the connector. You need to crimp it. There's cheapy crimping tools, which are only, you know, $3 or so. And if you get carried away for $11 or $12, there's a nearly professional crimping tool that does a really nice job. Okay, some of the other aspects of using the 75 ohm TV cable situation are that there's other accessories around that can be pretty helpful. For instance, excuse me a second. Shore up my voice a little bit. This is an ABC selector switch, which can allow you to select multiple antennas, for instance, or reroute signals. And another convenient 75 ohm accessory, they have these slide-on connector adapters that you can just do that instead of screwing the connector on. Some of the, pardon me, at Radio Shack. Get the catalog, look around, there's a lot of neat stuff there. If you have too much signal for a particular radio, there's variable attenuators you can put right in the line. And of course, there's a whole world of adapter connectors to go between the various coax connectors available. Yes?
How do you know if you have too much signal for the radio?
You'll have trouble. I mean, most tube radios never have that problem. Connectors, there's an L connector if you need to get in close to a wall or something like that. You can, now some of the other advantages of using cable of this sort, you can buy a wall outlet that has an F connector on it. You can run the 75 ohm cable up your wall right to your radio, have a nice, neat, tidy outlet to hook it to. So you can really get carried away on that, and none of this stuff is expensive. Wall outlets feed through tubes to the wall. The grounding block for the entry point is an aluminum casting that has a connector on each end and a place to screw your ground wire to it. And of course there's patch cords and attenuators and all sorts of things like that. There are a couple of 75 ohm accessories that won't work for general radio use, and these are the frequency sensitive things such as the two-way splitters and the distribution amplifiers. All of that stuff cuts off on the low end at about 10 megahertz. So it won't work at all in the broadcast band and will just barely work for shortwave. Okay. But I'll show you some solutions to that problem. So let's consider a system here. And this is kind of a lot of the things you might consider doing. You don't have to do all of this, but here are some of the possibilities. We have an antenna outside the house. We have an effective ground outside the house so that that ground doesn't pick up noise from the house. We achieve impedance matching with a 4-to-1 Ballon transformer at this point. Like I said, these things you don't know about yet, we'll tell you about in just a couple of minutes. This transformer not only does the impedance matching, but it effectively isolates that ground from that ground so that the noise picked up by the cable shields in here don't get into the antenna system. Here's a grounding block, a la Radio Shack, the entry point, safety ground here. Come inside somewhere. Here's a splitter. Now what a splitter does is it takes a 75 ohm signal and divides it into two 75 ohm signals. If you just put a T connector in there, you've caused an impedance mismatch and you lose a whole bunch of signal. A splitter will just send half the power down each wire and maintain the 75 ohm impedances. I've shown here an A-B switch. How do you tell if your antenna is working? How do you tell if you're making progress as you make improvements to your antenna system? Take your old antenna and an A-B switch and hook it to your receiver and do a comparison. Listen for improvements or degradations as you make changes to your system. I showed a communications receiver here. That's my weakness, and they're handy because they have things like S meters on them. Come down here, we have another splitter. One of the other advantages of a split ohms to be a more ideal match into maybe an old radio that needs some extra signal coming into it. And for those Catalan lovers among you, most of those radios have internal loop antennas, and you try to operate them in the house, you get a lot of noise. I'll show you how to build a loop coupler that you can set behind the radio without even touching it and get a clean signal into it. So we'll get down to the nitty-gritty of building some of these devices. There's a lot of ways to make we're basically talking about transformers. There's a lot of different ways to make them. I'm going to concentrate on one particular design that makes real easy to build broadband transformers that will allow you to accomplish things such as building effective balance and splitters. These are based on ferrite cores. You may be familiar with ferrite toroids, the donut-shaped core material sometimes used. But for wideband transformers, an even more effective core shape is the so-called binocular core. These are about ½ an inch long, made out of ferrite. And we're dealing with what's known here as a transmission line transformer. That is, you take a twisted pair of wires, which is really a transmission line, and you use it as the winding in a transformer. Binocular core, if you're just going to have one set of windings, one transformer that is, you go in one hole, around the end and out the other hole. One time around counts as one turn. Again, this is a tri-filler winding, that is 3 wires, 3 filaments twisted together. And it's 2 turns because it goes up and back, that's once, and up and back again, that's 2 turns. With slightly degraded performance in terms of low frequency response, you can use that same core to make 2 transformers by putting one winding through one hole. Through the hole once is 1 turn. Come down through the hole again is 2 turns. So this is actually 2 transformers wound on a single core here. These cores, in normal terms, are a little difficult to come by. Primary source is a company in California called Amadon Associates. We'll talk a little bit more about getting our hands on these things a little later here.
Now, there's a company in New York State, not far from here, Fair Institute, but you have the equivalent number?
I don't know their numbers. Okay, but we could work on that too. Okay. Let's take a look at the balanced to unbalanced transformer known as a balun. And let's start out by just looking at half of this drawing. We take a twisted pair of wires, we wrap it on this core, and what happens? Signals coming in this end, that is signals that are differential, positive on one wire, negative on the other wire, are transmitted down that transmission line and come right out the other end as though there was no transformer there at all. However, common mode signals, signals that are the same polarity on both of those lines, which is the case with noise on the shield of a piece of coax, for instance, are choked off by the inductance of the winding of the transformer. So that's the basic balun. That is, you can have a balanced circuit out here, which is not referenced to ground. And on this end, you can ground part of it and have an unbalanced circuit. Now, what we really want to, in addition, we want to use this balun principle to do two things. First of all, to separate the noise on the cable shield in your house from the ground system outside so that noise doesn't get back into your antenna. And the other thing we want to do is an impedance match, make this 75 ohm cable look like a higher impedance to the outside world. And we can do that with two balun transformers connected as so. The inputs on this side are connected in series, and the outputs on this side are connected in parallel. So that's effectively a 2-to-1 turns ratio, and the impedance ratio is the square of the turns ratio, so it's a 4-to-1 impedance ratio. So if we say that we have 75 ohms over here, we have a 300 ohm circuit out here. We can build that using one of these ferrite cores, one set of windings on one side, one set of windings on the other side, wired up like so. Pass this around. This is a Radio Shack $2 box. 5-way, I like to use 5-way binding posts. If you put these on this end on 3/4 inch centers, a dual banana plug will plug right into them. May come in handy. And I've provided another ground connection on this side so we can easily make connections to the coax shield coming out this end, and we'll talk about that here just a little bit more. So we improve the impedance match between the antenna and the coax. We take steps to keep any noise you pick up on the shield inside the house out of the antenna system. We can use this flopped around the other way to impedance match into the receivers. This design, as I doped it out here, will cover down to about 100 kilohertz and up past 30 megahertz.
Is that essentially the same balun as the commercially available $1 and $2 ones for cable TV?
It's the same sort of circuit, but the ones made for cable TV have a different kind of ferrite material in here, and they fall off in the low frequency end at about 10 megahertz. So they won't do what you need to do. This is the same design, redone, yeah, with different material, redone for radio weirdos like us.
Good from, give us the...
Oh, about 100 kilohertz to about 30 megahertz, give or take. But it'll do most of the radio things for you. And also, if you trace this, if this is your antenna here, you'll see that the DC path here goes like this, like this, like this, like this, and to ground. So that provides a positive DC ground on the antenna and eliminates any possible static buildup on the antenna. The cores come from Amadon. Their part number is BLN 73202. They're around $1 a piece. The windings are number 26 magnet wire. Give or take, number 30 is okay. Much bigger than number 26. You might not get all the turns in. And each of these windings is 7 turns of wire. If anybody has a good source of magnet wire that has low temperature insulation on it, talk to me after the presentation. A lot of magnet wire is made for winding motors, and it's all you can do to get the insulation off of it. You about have to scrape it off with a knife or paint remover or something. But there is low temperature wire, which you can just touch it with a soldering iron and solder, and the insulation melts right off, and it solders like a champ. That's the stuff you want to have if you can get it.
Before you take that slide up, is there 1 too many wires on that lower view there? It looks like you have the ground wire from the upper transformer going to ground.
There's a wire from this transformer that goes to ground, a wire from this transformer that goes to ground, this one, and a wire from here and a wire from here going to the 75 ohm output. That's it. I think that's correct. You can look at the sample. The sample works. Yes?
You ever try using RJ
Or is it too small for those cores?
Well, to do the winding? Yeah, you wouldn't get it through those cores.
They make bigger cores?
Yeah, you can. There's all kinds of things you can do here, but this is an approachable, easy to do design. Because of this core material, you can get away with just 7 turns of wire on it and still get the low frequency response. So I've worked at this for a while. This is a good design. You know, you can mess with it if you want, but if you just cookbook this, you'll come out with something that works. Okay, let's review a little bit what we can do with a transformer of that sort. What I designed it for was, as we said, impedance matching to that antenna and separating the ground in here from the ground out here. Now, these grounds will, in fact, be connected together through various stray paths, but it's worthwhile to get them decoupled. Now, there is a downside to this. If you just drive your 2 foot of copper pipe in the ground out here, you may find that you hook this up and the signals you get are not very strong because that ground is no good and it's half of your antenna. To test for this, just take a piece of wire and jumper around this way and see if things get better in terms of signal strength. That'll tell you that this ground out here needs some work. If you don't have an extra ground outside, you can still use this transformer with that jumper wire. In this case, the antenna is working against whatever ground you have connected inside on this side of the transformer. Also, because it's a balanced to unbalanced transformer, you can also use it to feed balanced antennas, like your classic dipole or doublet antenna. I didn't get into it, but there's a pretty easy switching method you can hook up here to run that dipole as a 2-element antenna for short wave, and just short these together, connect this guy to ground for medium wave, and that can be a pretty effective antenna system. Okay, that's the balun. Using the same core and the same number 26 wire, we can build a 3 dB splitter combiner. And what this consists of is there's an auto transformer here that steps the 75 ohms down to about 33 ohms at this point. And then on the output, there's a center tapped winding, which is what's known as a hybrid, because these, now one of the things you need to know about these drawings is the dots indicate one end of the winding. That is, these 3 wires are all twisted together, and that is say the beginning end of the winding. In each case, you need to maintain the polarity correctly. So that's what the dots are for, to remind you what the polarity is. This winding then takes these 2 75 ohm signals and makes them into a 37.5 ohm signal. So you're connecting 33 ohms to 37.5. That's a pretty good match. And the other thing that happens here is because of the phasing of these windings, any signal that comes in here cancels itself out, so it does not come out over here. This is the hybrid effect, and this achieves isolation between devices that are connected here and here. The 150 ohm resistor maintains the balance of all of that. I'm not even sure I understand it. You could operate the same transformer at 50 ohms, in which case you want to make that resistor 100 ohms instead of 150 ohms. So again, divides the input signal in half. There's no loss. Half the power comes out here, half the power comes out here. It's a 3 dB loss relative from here to here. But any other way you split it up, you'd throw power away. Bandwidth is approximately that, which is the frequency range of interest for what we're doing, I think. And it provides the isolation between the outputs. You can also use a transformer like this to combine multiple signals. For instance, suppose you had your signal coming in from your outside radio antenna here, off to your radio sets inside, and now you have a local AM, low power AM transmitter connected to your record player, which you run in here. And so now you've got a nice clean AM signal among all the rest of the garbage to listen to. We could talk about doing that at some later date too. Yes?
This relates back to the picture like you have a full-blown system where you have three.
Yeah, these are the splitters. In fact, here, I should have been passing this around. That's a commercial 75 ohm TV splitter that's had its guts ripped out and one of these guys put in it. And that's the way to do it, is take the, buy the $3 splitter, which already has all the connectors and everything, and throw the insides away and install your new transformer in it. You can pass that on around. Okay. One more construction project for you. As I promised, pass this guy around too. If you have a radio with a loop antenna, you try to operate it inside, you're in the noise field, it gets pretty noisy. You build yourself a little device like this. It's a piece of wood, it's pretty self-evident. If it's about that size, and the dimensions are not real critical, but about that size with about a baker's dozen turns on it, it's a pretty good match to the 75 ohm cable. You set it up behind your radio, and it couples a nice strong signal into it. It's just a piece of wood, an F connector, another piece of wood for a base, some hookup wire. When you wind a coil like this, you need an odd number of slots, otherwise the wires won't cross over on you. And that's pretty easy to do. Okay. One more thing I want to talk about here is this is an area of experimentation, getting yourself a good antenna. And yeah, you can throw an antenna up and listen to it and be happy with it. But if you really want to know if you did any good, you want to compare what you got now to the new one you build. An AD switch is highly recommended to do that. Just a box with a switch in it, or go buy one of the cable TV switches. The way I suggest you do this is that you choose yourself, you pick yourself an AM station that's noisy and nasty to listen to, and then you work to make it better. And you just do a comparison between the old antenna and the new antenna. Start out working in daylight so you're not dealing with sky waves and all this other signal fading and that kind of stuff. And if you have a communications receiver with an S meter, that can help you judge the signal strengths. But otherwise, what you want to do is, like I say, a marginal station that's a low enough signal strength that it's not really getting into the automatic volume control on your receiver, and you'll be able to hear that come up as you improve the performance of your system. It's my belief that the magic thing about old radios is that they play, and I like to play radios, and I've installed a fairly extensive system of this sort and developed essentially the transformers that you can't get your hands on to make that system work. I guess I'd like to challenge you all to improve your antenna situation at home. To that end, I have a couple of things here. For the first 3 really serious people, I have a couple of little kits with 2 cores and some number 26 wire for the princely sum of $2 a piece. Pardon the commercial. Also, I've got some freebies. I've got some vintage RCA brand made in the USA discharge devices. So anybody who can use those, help yourself to them. That's pretty much the end of my presentation. If there is interest in the future, well, I'll get to your question in a second, we could talk about some other things such as active antennas, where you use a very short antenna and an amplifier to bring the signal strength back up. I've got some background on those. The other thing we can talk about is distribution amplifiers. If you've got a whole bunch of radio sets And you don't want to just use passive splitters losing 3 dB each time. You need a broadband amplifier to bring the signal level up to survive the splitting. And that's something we could talk about as well. Okay, question?
Yeah, Al, what was that grounding block that's on that full-blown system?
Yeah, it's just called that, a grounding block available from Radio Shack. It's a aluminum casting about so big, has an F connector on each side of it and a screw to pick up the ground wire and a couple of holes and screws to screw it to the side of your house. And that's, you know, if you ground your coax coming into the house that way, that meets the electrical code, and it's a good way to ground the thing. Yes, sir?
How effective is your long wire in the attic rather than outside?
If that's the only place you can put in the antenna, then do it. But the problem is that it's within the noise field of your house. I mean, take an AM radio, little AM radio, and walk up to the wiring on your walls. You're going to hear all this racket, and that sort of surrounds your house as a shell. And if your antenna is in the noise field, it's better than no antenna, but it's going to be noisy. And so if you can in any way get the antenna outside the house, that's what you want to do. Yes?
Two quick ones on the 9, maybe one back there.
Okay, on which? 9. Oh, okay. Not quite full blown. You need a distribution amplifier and the AM transmitter hooked into
The
it.
discharge devices, see the first 41 valve, you know, where the antenna is?
What
The discharge device, would that go?
what I assumed here was the following. This guy's providing a DC path to ground here. If you have a lightning strike, yeah, it might fry that guy, a direct strike. This grounding block is legal protection. That's all you need is that grounding of the coax shield where it comes into your house. That's per the code.
That would be your outside ground.
Yeah, that would be your outside ground.
House rod ground.
Right.
So that, you wouldn't need the ground.
Well, I would still put a ground rod right. I think they still want you to put a ground rod right there where that enters the house.
You need the first ground on the balance one, right?
Yeah.
You wouldn't.
Well, in this case, this is a sort of extreme, complete case, and this ground is 3/4 of a mile of copper wire buried in your front lawn.
Oh,
Okay. You may or may not do that, but that's.
Now, the second thing is, the second balance before the AC set, before
Yeah.
the signal, what's the purpose of the second balance?
The input impedance of most tube radios is somewhere in the neighborhood of 300 or 400 ohms.
Okay, so that's the matching between the
That's
splitter.
between the splitter and the radio.
You need to use a balance for that?
Well, it could be an auto transformer. It doesn't have to be balanced. Okay, I just said, well, you know, use the same one. It's this.
Are you better off with the balance?
Not necessarily. No advantage to a balun there, but it still takes one core and some wire, so you know it'll work just as well. Anything else? Yes, we're done. Okay. Yeah. We'll talk about it offline.